Virginia, 1831. Cyrus McCormick stands in a wheat field, watching his machine fail. The wooden contraption chatters across the ground, mangling stalks instead of cutting them. Farmers line the fence, arms crossed, shaking their heads. Another inventor promising to replace the cradle scythe with some mechanical absurdity that cannot possibly work. But McCormick sees something they do not see. The failure is not in the concept, but in the execution. And the difference between those two things is about to reshape American agriculture forever. The tyranny of the cradle. For thousands of years, harvesting grain meant one thing: pain. The kind that starts in your lower back at dawn and spreads through your shoulders by noon. The kind that makes your hands cramp around the wooden handle and turns your fingers into claws by sunset. This was not poor technique or weak character. It was the physics of feeding civilization. The cradle scythe represented the peak of manual harvesting technology. 5 wooden fingers curved above a 4-foot blade, catching cut grain and laying it in neat rows. A skilled man could cut 2 to 3 acres per day if he started before sunrise and worked until he could no longer see the grain. This sounds impressive until you understand the prison it created. Wheat has a harvest window of about 2 weeks. Wait too long and the grain shatters from the stalk, lost to the ground. Cut too early and the kernels are soft, vulnerable to rot. For a farmer with 40 acres of wheat, the mathematics were unforgiving. One man harvesting 2 acres per day meant 40 acres required 20 days of perfect weather and perfect health. But the weather is never perfect, and bodies break down. The solution was to hire help. During harvest season, entire communities mobilized. Farmers paid premium wages, sometimes doubling what they paid for other labor. The cost could consume the entire profit margin of the crop. But even money could not solve the fundamental problem. There were not enough men. As settlement pushed westward, farms grew larger. 100 acres, 200 acres, 500 acres. The land could grow more wheat than human backs could harvest. Settlers who had claimed rich prairie soil watched their crops ripen, knowing they could not possibly cut it all before the grain shattered and their investment rotted in the field. The economic trap was suffocating. You could own the best land, plant at the perfect time, receive ideal weather, and still lose everything because your harvest capacity was limited by the number of men you could convince to swing a scythe. Inventors had tried to mechanize harvesting for decades, but every prototype failed. The blade snagged on uneven ground, the cut stalks scattered instead of laying neatly. The mechanism required more force than a horse could provide, or it worked for 10 minutes before breaking down, leaving the farmer with an expensive pile of scrap metal in his field. The farming community drew a reasonable conclusion. Harvesting was too complex for machinery. The cradle scythe was not perfect, but it worked. And in agriculture, reliable mediocrity beats unreliable innovation every single time. This was the world Cyrus McCormick inherited. A world where the mathematical prison was accepted as an unchangeable fact of agricultural life. You could not grow more wheat than men could cut. That was the law, until it was not. The inherited problem. Robert McCormick was a blacksmith, an inventor, and a man intimate with failure. For 2 decades, he worked in his Virginia forge, trying to build a mechanical reaper that could match the efficiency of a man with a cradle scythe. He understood metal, he understood leverage and force, but every machine he built disappointed him in the field. His prototypes demonstrated the classic inventor's trap. They worked beautifully in theory, functioned adequately in the workshop, and collapsed under the chaos of real farming conditions. A blade that cut cleanly through wheat standing straight would jam when the stalks leaned from wind or rain. By 1831, Robert McCormick was ready to abandon the project entirely. His son Cyrus approached the problem from a different angle. Cyrus was 22 years old, working the family farm, and intimately familiar with the brutality of manual harvesting. He had swung the cradle scythe. He understood the harvest window not as an abstract concept, but as a physical deadline that determined whether his family ate well that winter. This perspective mattered. His father had approached the reaper as a mechanical problem, trying to replicate the motion of the scythe in metal and wood. Cyrus understood that replication was the wrong goal. The machine did not need to swing like a man. It needed to cut like a saw, continuously and without stopping. The technical challenges were specific and unforgiving. The cutting mechanism had to operate close to the ground without catching on dirt. It had to separate the grain to be cut from the grain to be left standing. It had to gather the cut stalks and lay them neatly. It had to be light enough for horses to pull without exhausting them, yet strong enough to withstand the vibration of fieldwork. And the entire system had to be simple enough that a farmer could operate it without mechanical training. Each requirement contradicted at least one other requirement. Previous inventors had failed because they tried to solve all 5 problems simultaneously, creating elaborate mechanisms that were brilliant in concept and useless in practice. Cyrus McCormick understood that complexity was the enemy. He stripped the problem down to its essentials. What is the minimum mechanism required to cut standing grain and leave it in a condition where humans can bundle it? The answer required abandoning his father's approach entirely. Robert had tried to create a vertical cutting blade that mimicked the scythe's arc. Cyrus envisioned a horizontal blade with a reciprocating motion, moving back and forth like a handsaw, cutting against stationary fingers that held the stalks in position. The motion was nothing like human harvesting. It was industrial, mechanical, and completely unlike anything farmers expected. Cyrus McCormick spent the winter of 1830 to 1831 building his first prototype, knowing that success meant not just solving the mechanical problems, but also breaking through a cultural wall of skepticism built by decades of failed inventions. The mechanical breakthrough. The machine that Cyrus McCormick built in 1831 combined 7 essential components into a system that would become the template for mechanical harvesting for the next century. Each component was simple. The genius was in how they worked together. The cutting blade was a straight steel bar with triangular teeth, mounted horizontally about 4 inches above the ground. This blade did not swing or rotate. It moved back and forth in a reciprocating motion, driven by gears connected to the main drive wheel. The stroke was short, perhaps 6 inches, but rapid. The blade made dozens of cuts per second, creating a sawing action that sliced through wheat stalks cleanly without the leverage required for a swinging blade. The stationary fingers were the counterpart to this moving blade. These were rigid metal projections, shaped like thick combs, that extended forward from the machine's frame. As the blade reciprocated, it cut against these fingers, trapping each stalk between the moving blade and the stationary finger. This created a scissor action without requiring the blade itself to move in an arc. The stalks could not escape because the fingers held them in position. The platform was a flat wooden surface mounted behind the cutting blade. As the blade cut the stalks, they fell backward onto this platform instead of dropping to the ground. A man walked alongside the machine, raking the cut grain off the platform at regular intervals, depositing neat bundles for the binding crew following behind. The reel was McCormick's solution to a problem that had destroyed previous designs. Standing grain does not stand perfectly straight. Wind, rain, and uneven growth cause stalks to lean in different directions. The reel was a rotating cylinder mounted above and slightly ahead of the blade, fitted with wooden slats. As it turned, the slats swept through the standing grain, pushing it backward against the blade's cutting edge. This forced the stalks into the cutting zone regardless of how they were leaning. The drive wheel was the heart of the system's power transmission. It was a large wooden wheel, 5 feet in diameter, positioned on the side of the machine. As horses pulled the reaper forward, this wheel rolled across the ground. Its rotation drove a series of gears that powered both the reciprocating blade and the rotating reel. The machine's forward motion created the energy needed to operate all its cutting mechanisms. The frame held everything together in precise alignment, made from wood reinforced with iron brackets, designed to flex slightly under load without breaking. The divider was a vertical blade mounted on the right side of the cutting bar, separating the grain being cut from the grain being left standing. The physics that made this system work was elegant in its simplicity. McCormick's reciprocating blade required much less force. Because the cutting stroke was short, and the grain was trapped against stationary fingers. The blade did not have to generate enough force to slice through a stalk by itself. It only had to move back and forth, while the fingers did the work of holding the stalk in position. This meant horses could provide adequate power without exhausting themselves. McCormick filed his patent application in 1834, 3 years after his first successful demonstration. The delay was deliberate. He spent those years testing, refining, and proving that the machine could survive multiple harvest seasons without fundamental design changes. The breakthrough was not in inventing new components. What McCormick invented was the specific combination and arrangement that allowed these components to function together in the violent, unpredictable environment of a grain field. He had not created new technology. He had created a new system. The skeptics. The first public demonstration of McCormick's reaper in 1831 was not a triumph. It was a spectacle of doubt. Farmers gathered along the fence of the test field in Rockbridge County, Virginia, watching this wooden contraption clatter across the wheat. The machine made sounds no one had heard before. The reciprocating blade created a rapid clicking. The drive wheel rumbled. The reel whooshed through the standing grain. It sounded industrial, mechanical, wrong. The skepticism ran deeper than the unfamiliar noise. Farming communities in the 1830s valued skill above all else. The fastest cradlers, the strongest plowmen, the most efficient harvesters earned respect and higher wages. They had spent years developing their craft. McCormick's machine threatened to make all of that expertise worthless. If a mechanical reaper could cut more grain than the best cradler, what happened to the men who had built their livelihoods around being exceptional with a scythe? The economic fear was immediate and specific. Harvest season was the one time of year when laborers could demand premium wages. Mechanization meant those wages would vanish. Cultural attachment to manual methods was not irrational resistance to progress. It was a reasonable response to the failures that had come before. Farmers had watched inventors promise mechanical solutions for decades, seen those machines break down in the field, and return to the reliability of hand tools. The cradle scythe might be brutal work, but it functioned. Early demonstrations did not help McCormick's case. The machine worked, but not perfectly. It left patches of uncut grain when the field was uneven. It occasionally jammed. These imperfections gave critics ammunition. See, they would say, the machine cannot match the quality of human work. But McCormick understood something his critics did not. The machine did not need to be perfect. It only needed to be good enough and fast enough to matter economically. The demonstration that changed everything happened in 1844, 13 years after his first prototype. In a public competition, McCormick's reaper cut 6 acres of wheat in a single afternoon. The best cradlers working alongside managed 2 acres in the same time. The mathematical proof was undeniable. One man operating the reaper, with one other man raking cut grain off the platform, accomplished the work of 3 men with cradle scythes. The economics flipped instantly. The resistance began to crack. Farmers who had dismissed the reaper as an expensive curiosity started asking about price and delivery. The question changed from whether mechanical harvesting was possible to whether they could afford to be left behind. McCormick recognized that his market was not the established farming regions of the East. It was the frontier, where the old methods had already failed, and farmers were desperate for solutions. In 1847, he made the decision that would transform his invention from a local curiosity into an industrial empire. The Chicago Gamble. In 1847, Cyrus McCormick was 38 years old, operating a small manufacturing operation in Virginia and facing a strategic choice that would define the rest of his life. He could stay in the East, where manufacturing infrastructure was established and markets were familiar, or he could move his entire operation to Chicago, a muddy frontier town barely 2 decades old. He chose Chicago. The decision looked insane to everyone who knew him. Chicago in 1847 was not the industrial metropolis it would become. It was a collection of wooden buildings on swampy ground at the southern tip of Lake Michigan. The population was around 16,000. There was no established manufacturing base, no skilled labor pool, no reliable transportation network. It was, by any rational measure, the worst possible location to build a factory. But McCormick saw what others missed. Chicago sat at the exact intersection of three forces reshaping American agriculture. To the west, the prairie states were opening up, millions of acres of wheatland with almost no harvest labor available. To the east, the Erie Canal and the Great Lakes provided a water route to eastern markets. And railroads were beginning to push westward. Chicago was positioned to become the hub where western grain met eastern demand. More importantly, Virginia was the wrong place to sell reapers. The farmers who needed his machine were not the ones who could easily visit his factory. They were scattered across the expanding frontier, hundreds of miles from Virginia. McCormick rented a factory building on the Chicago River and began production immediately. The first year, he manufactured 500 reapers. Each machine represented a BET that a farmer would pay $120, roughly equivalent to 4 months of wages for a skilled worker, for a device most farmers still considered experimental. The genius was not in the manufacturing, but in the business model McCormick created around it. He understood that farmers could not afford to pay cash for a reaper, especially when they were not certain it would work. So he invented installment buying for agricultural equipment. Pay $30 down, harvest your crop, and pay the balance from your earnings. If the reaper failed, you were not ruined. If it worked, it paid for itself. This financing innovation was as revolutionary as the machine itself. McCormick was not just selling machines, he was selling the possibility of expansion. He also built a dealer network that had not existed before in agricultural equipment. Local agents demonstrated the reaper, took orders, arranged financing, and provided basic repairs. These dealers earned commissions on sales, which meant they were motivated to ensure farmers succeeded with the machine. McCormick implemented standardized parts, allowing repairs to be made with components shipped from Chicago. He published instruction manuals. He offered guarantees, promising that if the reaper could not cut at least 1.5 acres per hour, he would refund the purchase price. Every element of this system was designed to reduce the farmer's risk and increase adoption. The financing made it affordable. The dealer network made it accessible. The standardization made it maintainable. The guarantee made it trustworthy. The gamble paid off almost immediately. By 1850, he was producing over 1,000 reapers per year. By 1855, production exceeded 4,000. Chicago transformed from a frontier town into an industrial hub, partly because McCormick had chosen it as the base for his manufacturing empire. The city that had looked like an insane choice in 1847 became the obvious choice by 1860. The exponential flood, the numbers tell a story of agricultural conquest so rapid it defied comprehension. In 1845, Cyrus McCormick sold 50 reapers. In 1850, over 1,000. By 1860, annual production exceeded 4,000 machines. But these numbers do not capture the full scale of transformation. Every reaper sold multiplied harvest capacity by a factor of 3 or more. Farmers who bought reapers in 1850 were harvesting double or triple their previous acreage by 1851. The constraint that had governed agriculture for millennia, the limit of human harvest capacity, simply vanished. If you could plow it and plant it, you could harvest it. This created a land rush. Settlers pushed farther into the prairie states, claiming sections that would have been impossible to harvest manually. Kansas, Nebraska, Iowa, Minnesota, the wheat belt expanded westward at a pace that matched the spread of the reaper. The machine did not just improve existing farms, it created farms that could not have existed without it. Competition arrived quickly. Obed Hussey had patented his own reaper design in 1833. John Manny developed a machine with significant improvements. The agricultural machinery industry became a battlefield of patents, lawsuits, and aggressive marketing. The most significant demonstration happened not in America, but in London. In 1851, the Great Exhibition showcased industrial achievements from around the world. McCormick shipped his reaper to England and demonstrated it in a wheat field outside the city. The British agricultural establishment watched with skepticism that turned to shock. The crude American machine outperformed every European harvesting method. The war in Crimea from 1854 to 1856 changed everything. The conflict pulled agricultural laborers into military service, creating exactly the labor shortage that made mechanical harvesting necessary. British and French farmers, facing crops they could not harvest, suddenly became desperate customers for American reapers. The Civil War had the same effect in America, but amplified. When war broke out in 1861, hundreds of thousands of young men left farms to join armies. The reaper became essential to Union victory. Northern farms, mechanized with reapers, maintained grain production despite losing men to the military. The South, with less adoption of mechanical harvesting, struggled to maintain agricultural production. The reaper did not win the Civil War, but the grain it harvested fed the army that did. By 1870, McCormick's factory in Chicago was the largest agricultural machinery manufacturer in the world. The reaper had moved from experimental technology to standard equipment, but the most profound transformation was not the one anyone had predicted. The reaper had created a hunger for a different kind of power, one that would reshape rural America in ways Cyrus McCormick never imagined. The Hidden Revolution. The title promised that the reaper made horses obsolete. That statement is backwards. The reaper did not eliminate horses. It created the horse economy. Before mechanical harvesting, horses on farms were primarily transportation animals. They pulled wagons and they carried riders. The heavy work of agriculture, plowing, harrowing, and harvesting was often done by oxen. Oxen were stronger, cheaper to feed, and more docile. They moved slowly but consistently, perfect for the steady pace of manual farm work. The reaper changed this equation completely. Operating a mechanical harvester required speed and endurance that oxen could not provide. A reaper needed to move at 3 to 4 miles per hour to cut efficiently. At that speed, the blade's reciprocating motion and the reel's rotation created the cutting action that made the machine work. Oxen could not maintain that pace. Horses became not just preferable, but essential. This created immediate demand for more horses and different kinds of horses. Farmers needed draft horses, large, powerful breeds capable of sustained pulling force. The numbers reveal the transformation. In 1840, the United States had approximately 4 million horses. By 1860, that number had grown to over 6 million. By 1890, it exceeded 15 million. This explosion was not driven by transportation needs. It was driven by agricultural mechanization. Operating a reaper required 2 to 4 horses depending on field conditions. But horses cannot work continuously. Smart farmers kept 4 horses, rotating them to prevent exhaustion. This meant investing significant capital not just in the reaper, but in the power source to run it. A good draft horse cost $50 to $100 in the 1850s. 4 horses represented an investment equal to or greater than the cost of the reaper itself. The economics forced a recalculation of farm operations. Farmers who bought reapers had to also invest in horses, which required investing in feed production, which required more land dedicated to oats and hay. The reaper did not simplify farming. It industrialized it. The irony is that this massive investment in horsepower was temporary. The horse economy that the reaper created would be destroyed by the tractor in the early 20th century. Farmers who spent decades building up their horse stocks would watch that entire infrastructure become obsolete within a generation. This hidden revolution demonstrates a pattern that repeats throughout technological history. Innovations rarely create the future their inventors imagine. McCormick thought he was solving a harvesting problem. What he actually did was create a 60-year era of horse-powered industrial agriculture that would then be swept away by the next wave of mechanization. The reaper did not make horses obsolete. It made them temporarily indispensable, which turned out to be worse. The harvest that changed America. The McCormick Reaper did not just change how grain was harvested. It changed what America could become. The connection between mechanical harvesting and westward expansion was not coincidental. It was causal. Before the Reaper, settling the prairie states was economically marginal. The land was rich, flat, and ideal for grain production. But farms larger than 100 acres were impractical because harvest capacity limited what you could plant. A family with 4 working adults might manage to harvest 50 acres before the grain shattered. Claiming a section, 640 acres, was possible under the Homestead Act. Actually, farming it was not. The Reaper broke this constraint completely. A farmer with 2 reapers could harvest 200 acres in a week. Suddenly, the massive farms that the prairie land made possible became economically viable. Settlers who claimed land in Kansas and Nebraska in the 1860s were not gambling on subsistence farming. They were building commercial grain operations designed to feed distant cities. This created a feedback loop with railroad expansion. Railroads pushed westward to connect to these new grain-producing regions. Farmers bought reapers because railroads provided access to markets. Railroads built more lines because farmers were producing surplus grain that needed shipping. The reaper and the railroad were not separate innovations. They were parts of the same system that industrialized American agriculture. The impact on Civil War food production cannot be overstated. The Union maintained agricultural output despite losing hundreds of thousands of men to military service, because mechanized harvesting reduced labor requirements. Confederate states, with less mechanization and an agricultural system built on slave labor rather than technology, struggled to feed their armies and civilian populations. The industrial North's advantage was not just in manufacturing weapons, it was in manufacturing food. After the war, something fundamental shifted in American farming culture. The goal was no longer feeding your family and selling a small surplus to local markets. The goal was maximizing acreage and selling into national commodity markets. Farmers who mechanized early, who bought reapers and expanded their operations, prospered. Those who continued manual methods could not compete on price and were driven out or absorbed into larger operations. This shift from subsistence to commercial farming destroyed regional food systems that had existed for generations. Before the Reaper, most communities produced most of their own food. Local mills ground local grain into flour. Local butchers slaughtered local cattle. The food supply was decentralized, diverse, and resilient. Crop failure in one region did not affect food availability in another region. Mechanical harvesting and railroad distribution centralized food production. Wheat grown in Kansas, milled in Minneapolis, and shipped to Boston became cheaper than wheat grown, milled, and consumed locally in Massachusetts. Farmers in older agricultural regions could not compete with the efficiency of prairie wheat operations. They abandoned grain production, specialized in other crops, or left farming entirely. The creation of grain futures markets in the 1870s and 80s was a direct consequence of mechanical harvesting making grain a standardized bulk commodity. Before the Reaper, wheat was bought and sold locally, in small quantities, with quality assessed by individual inspection. After mechanization, grain became fungible. A bushel of number 2 hard red winter wheat from one farm was identical to a bushel from another farm 1,000 miles away. This standardization allowed financial markets to treat grain like any other commodity. Traders could buy and sell contracts for future delivery without ever seeing the actual wheat. Speculation became possible, then inevitable. Farmers who simply wanted to grow grain found themselves competing with financial operators who bought and sold futures contracts to profit from price movements. The system was more efficient. It was more productive. It fed more people at lower prices than had ever been possible before, but it also destroyed the independence that farmers had valued. Success now depended on decisions made in Chicago trading pits, on railroad shipping rates set by distant corporations, on weather patterns across entire regions, rather than individual farms. The mechanization that had promised to liberate farmers from backbreaking labor had instead bound them into a global economic system they could not control. The Reaper had accomplished exactly what Cyrus McCormick intended. It had solved the harvest bottleneck. But in solving that problem, it had created dozens of new problems that nobody had anticipated. The legacy. Cyrus McCormick died in 1884, a wealthy man presiding over an industrial empire. His company continued innovating after his death, developing the twine binder in the 1870s, which automated the bundling process, and the combine harvester, which merged reaping and threshing into a single operation. In 1902, the McCormick Harvesting Machine Company merged with its major competitors to form International Harvester, creating one of the largest agricultural equipment manufacturers in the world. The Reaper evolved into the modern combine, a machine that cuts, threshes, and cleans grain in one pass through the field. Today's combines bear almost no resemblance to McCormick's 1831 prototype. They are powered by diesel engines producing hundreds of horsepower. They are guided by GPS. They adjust their settings automatically based on real-time analysis of crop conditions. But the fundamental principle remains identical. It replaces human labor with mechanical systems that can work faster and longer without fatigue. This principle, mechanize or die, has governed agriculture since McCormick's first successful demonstration. Farms have grown larger because machinery allows one person to cover more acres. The number of people working in agriculture has declined from over half the population in 1850 to less than 2% today. Food has become cheaper and more abundant than at any point in human history. But the pattern McCormick established continues to repeat. Every wave of agricultural mechanization promises liberation from drudgery and delivers consolidation and dependency. The farmer gains efficiency but loses autonomy. The Reaper freed farmers from the cradle scythe but bound them to horse teams, equipment debt, and commodity markets. The tractor freed them from horses but bound them to fuel costs and maintenance expertise. Modern precision agriculture promises to optimize every aspect of farming but requires farmers to become data analysts operating equipment they cannot repair. The irony McCormick could not have foreseen is that the horse boom his machine created was a temporary phenomenon, destroyed by the tractors that followed. The farmers who invested heavily in draft horses in the 1880s watched that investment become worthless by the 1920s. The pattern suggests a question about contemporary agriculture. What are we investing in now that will be rendered obsolete by the next wave of mechanization? What dependency are we creating today that we will regret tomorrow? The Reaper saved American agriculture from the tyranny of manual harvest. Whether what came after was actually freedom remains an open question.